In this video, I am going to demonstrate how you can use the gmodels package to calculate the chi-square. The chi-square test provides a method to compare categorical variables regardless of how many categories each contains. This goes beyond simply looking at tables, as we did earlier, as the chi-square test is a type of hypothesis testing. In other words, it's a test of type 1 error, and type 1 error is the error in which we conclude there is a difference but one does not exist. So chi-square provides us with the probability that we're making a type 1 error. You should also be aware that there are situations in which both variables are dichotomized. That is, there's only two categories, or sample size may be small. In these cases, another test, Fisher's exact, may be more appropriate. So in terms of hypothesis testing, since we're addressing the relationship between categorical variables, in this we first need to construct both a null and alternative hypothesis. In all cases, we will be testing similar hypotheses. So we could test we're testing the null, there is no association between the variables, and the alternative would be there is an association between the variables. So in the dataset Hospital 1, we have the independent variable gender, which has two categories, male and female. So we could test the null hypothesis that male and females are equally likely to return within 30 days. The alternative would be males and females are not equally likely to return within 30 days. So let's begin by loading the gmodels package by scrolling down to gmodels and clicking the checkbox. The next step is to use the options command in R to remove something called scientific notation, and you should probably do this anytime you're doing any kind of hypothesis testing of type 1 error in R. And I'm going to type in sci pen =, and then 999. Just make a notation of this and do this every time you are going to have a session in which you're doing statistical testing or hypothesis testing. Okay, so now I'm going to go ahead and open up the Hospital 1 data set, which is on my desktop. I'm going to load it in, and I'm just going to open the spreadsheet. Okay, so now the function we're going to use is the cross table function in the gmodels package. So I'm going to type in cross table, and it flies out. So we have RStudio helping us out here, and I'm going to type in the data set, Hospital 1, and then dollars followed by a $, and the dependent variable first, return 30, followed by the independent variable, and I'll do Hospital 1 and $, and let's scroll down to gender, or up to gender, I'm sorry, and put that in. And now we have to follow that with the chi-square command. So I'm just going to type in chi. So we get fly out from RStudio, click on it, and then just follow the equal sign with a capital T, which means yes, you want it true. And hit enter. And now we have our table. So first let's look at the table. Since the independent variable is on the column, I'm going to look at the percentages along the column and compare across, which would be the fourth value. So here we have 78% of females who are in the no return compared to males being 85.6%, slightly more, are not returning. Now here, when we look at the yeses, we see a fairly big difference. That difference was only was less than 10%. Here we have a slightly larger difference, but not that large. Again, it's less than 10%. So if we go ahead and look at the chi-square, it's above 0.05. And if you recall, our criteria for rejecting the null hypothesis is having a p-value of 0.05 or less, which would mean a chance of making a type 1 error of 5% or less. Here it's above 5%, so we have to accept the null hypothesis that male and females are equally likely to return within 30 days. Now we can, for thoroughness, we can try doing a Fisher's. So I'm just going to press the up arrow, and which will repeat the command, and I'm just going to replace chi-square with Fisher. And I'm going to hit return, and here the p-value 2 is also above 0.05. It's 0.2882639. So again, we will be accepting null hypothesis. Now let's test another hypothesis that looking at the age 80 variable as an independent variable, in which we have two groups: patients below 80 years of age and patients 80 years of age and above. So the null hypothesis would be that patients above and below 80 years of age are likely to return within 30 days. The alternative would be that patients above and below 80 years of age are not likely to return within 30 days. So let's go ahead and test that hypothesis. So I could press the up arrow and I would get the cross table command I did previously, and I can just replace gender with age 80. But I think I'll go through the entire process by typing in cross table and then hospital and then $ return. Oops, it should be hospital 1. So I'm just going to go back and type hospital 1 and then $. I get the fly out and go to return 30, comma, hospital 1, $, and let's look for age 80. Here it is, and comma, chi-square. Gotta spell it right though. Chi-square, and I'll just click on the chi-square here and equals t and hit enter. Okay, so let's look at the relationship. So I'm going to go right to the yeses, and you can see that 11.1% of those below the age of 80 returned within 30 days compared to 32.6%, which is a pretty big difference. So we could also go up and look at the no's, and we have 88.9% and compared to 67.4%. So of course the no's, those who are below 80, a larger number of them are no's. So let's see if it's statistically significant. The p-value here is below 0.05. It's 0.001, which is smaller than 0.05. So we can reject the null hypothesis and conclude that patients above the age of 80 are more likely to return within 30 days. So that's an important piece of information. So to be thorough, let's again do the Fisher exact. And I'm press the up arrow to get back to previous command. And I'm just going to place that with Fisher. And I'm gonna it only should be one equal sign. And here the p-value again is below 0.05. It's 0.002. So we can conclude then that patients who are 80 years or above are more likely to return within 30 days. So again, chi-square is a measure of type 1 error when you're comparing two categorical variables.